Good afternoon everyone. Today I am going to present on the topic Binomial Theorem. Introduction. The first mention of the Binomial Theorem was in the 4th century BC by a famous Greek mathematician by name of Euclid. The Binomial Theorem is a mathematical rule that describes how to expand a two-term expression raised to n power. It's useful in algebra and for determining permutations, combinations and probabilities. Let the algebraic expression be x plus y whole to power n. The binomial theorem states the principle for expanding this expression and expresses it as a sum of the terms involving individual exponents of variables x and y. Each term is a binomial expansion is associated with a numeric value which is called coefficient. Statement. According to the binomial theorem, it is possible to expand any non-negative power of binomial x plus y into a sum of the form x plus y whole to power n equal to nc naught x to power n y to power naught plus nc1 x to power n minus 1 and y to power 1 plus nc2 x to power n minus 2 y to power 2 plus 2ncn minus 1 x y to power n minus 1 plus ncn plus x to power 0 and y to power n, where n is greater than or equal to 0 is an integer and each nck is a positive integer known as a binomial coefficient. Note, when an exponent is 0, the corresponding power of expression is 1. The multiplicative factor is often omitted from the term. Therefore, often the right-hand side is directly written as nc naught x to power n plus so. This formula is also referred to as the binomial formula or the binomial identity. Using summation notation, the binomial theorem can be given as the following. Example. Let us expand x plus 3 whole to power 5 using the binomial theorem. Here, y equal to 3 and n equal to 5. On substituting and expanding, we get x plus 3 whole to power 5 equal to 5c naught x to power 5 3 naught plus 5c1 x to power 5 minus 1 3 1 plus 5c2 x to power 5 minus 2 3 to power 2 plus to the 5c5 x to power 5 minus 5 and 3 to power 5. And by continuing the steps, we get x to power 5 plus 15 x to power 4 plus 90 x to power 3 plus 270 x to power 2 plus 405 x plus 243. Binomial theorem formula. The binomial theorem formula is used in the expansion of any power of a binomial in the form of a series. The binomial theorem formula is as follows, and where n is a positive integer and a, b are real numbers and 0 to r is from the range 0 to less than equal to n minus n. This formula helps to expand the expression such as x plus a whole to power 10, 2x plus 5 whole to power 3, x minus 1 by x whole to power 4 and so on. The binomial theorem formula helps in the expansion of a binomial raised to a certain power. The binomial theorem states if x and y are real numbers, then for all n belongs to natural numbers. It's like x plus y whole to power n can be expanded as follows, and where NCR is equal to n factorial by r factorial into n minus r whole factorial. Properties of binomial theorem. The number of coefficients in the binomial expansion of x plus y whole to power n is equal to n plus 1. There are n plus 1 terms in the expansion of x plus y whole to power n. The first and the last terms are x power n and y to power n respectively. From the beginning of the expansion of x plus a whole to power n, the powers of x decrease from n up to 0 and the powers of a increase from 0 up to n. The general term in the expansion of x plus y whole to power n is the r plus 1 term that can be represented as t r plus 1, t r plus 1 equal to n ncr x to power n minus r by r. The binomial coefficients in the expansion are arranged in an array which is called Pascal's triangle. This pattern developed is summed up by the binomial theorem formula. In the binomial expansion of x plus y whole to power n, the r term from the end is n minus r plus 2 with term from the beginning. If n is even, then in x plus y whole to power n, the middle term equals n by 2 plus 1, and if n is odd, then in x plus y whole to power n, the middle terms are n plus 1 by 2 and n plus 3 by 2. Applications of binomial theorem in real life. First, probability and statistics. In gambling and games of chance such as poker or blackjack, understanding probabilities is crucial for making strategic decisions. The binomial theorem helps calculate the odds of specific card combinations or outcomes, aiding players in determining their best course of action. For instance, it helps calculate the probabilities of various outcomes in situations involving multiple independent trials with two possible outcomes such as coin tossing, card games or genetics, example Punnett squares in biology. Second, genetics and biology. In genetics, the binomial theorem plays a vital role in understanding inheritance patterns. For instance, it can predict the probability of offspring inheriting a particular genetic trait such as eye color or blood type based on their parental genotypes. Third, finance and investment. In the field of finance, the binomial theorem is integral to option pricing models such as binomial option pricing model. This model considers multiple future price movements of an underlying asset to determine the fair value of options. Investors use this information to make decisions regarding buying, selling, or hedging financial derivatives. Fourth, medicine and healthcare. In epidemiology, the binomial theorem assists in modeling the spread of infectious diseases and assessing the effectiveness of public health interventions by simulating disease transmission dynamics. Epidemiologists can evaluate the impact of vaccination campaigns, social distancing measures, and other